Welcome to 8.3 area problems. In this section, we are going to use the same formulas as we used in 8.1 and 8.2. For instance, on the problem that you see in front of you, we're going to be doing the area of rectangles, which mathematically is not a hard concept. But what is difficult about these problems is they're word problems, and when we have word problems, some people start to get freaked out. But really, word problems is where it's at, because when we are in the world and we're applying the math that we learn, they are in the context of word problems. And we might not see the words, but they're in the context of an application. So it's not just about the math. In order to be successful at these problems, you can't just be good at the math. You also have to be good at organizing your thoughts, at taking a moment to really figuring out what do I need to know and how do I organize that. Because if you just start in with crunching numbers, you might get to the final answer, but there's a bunch of other times where you're going to end up getting confused in the process. So at the beginning up here, notice I wrote down, with multi-step word problems, organize your thoughts and your work to be successful. Breaking the problems into multiple parts and showing your 4 steps can be helpful. So example 1. Bert's Big Time Bakery has baked the world's largest chocolate cake. It is 600 centimeters by 400 centimeters by 180 centimeters tall. Bert wants to apply the frosting to the 4 sides and the top. How many liters of frosting does he need if 1 liter of frosting covers an area of about 1,200 square centimeters? Draw a top view, front back view, and left side and right side view. Notice I've already started to organize. I did a little bit of work ahead of time and thought through, well, if I'm going to do this problem well, I really need to think about what I'm going to have to find. A cake has 6 sides to it. However, when we are frosting a cake, we are not frosting one of those sides, right? We're not frosting the bottom of the cake. So when we're trying to figure out the total amount of area here, we really need to think about the sides of a rectangular prism, of a box, so to speak, and the top will be frosted, of course, but not the bottom. The front and back sides of the cake will need to be frosted. And then the left and right sides of the cake will need to be frosted. So sketching that out and thinking about that we really need 5 parts here: top, front, back, left, and right, to get our total area. So if we break that out and organize it now into those separate calculations, it makes the problem seem a little bit easier, and it might involve a little bit more writing, but I think in the end we'll understand it better. So let's take a look at the top view over here. So the top view of the cake means that we're going to do the area of this rectangle, and this rectangle, if we take the dimensions above, we're going to take the longer side, 600 centimeters, and basically the depth or the width of the cake at 400 centimeters. And we're going to do the area for that. So area is equal to base times height. Area is equal to 600 centimeters times 400 centimeters. And that means our area is 240,000 square centimeters. So that would be the area of the top of our cake. The front and back, so let's think about the dimensions up here. The front is going to be 600 centimeters across. And then we need to be thinking about how tall the cake is. So it said 180 centimeters is how tall the cake is. Now, when we do the area formula, we're going to have area is equal to base times height for rectangle, but we're going to multiply that by 2 because we're doing the front and the back. So area is equal to 600 times 180. All right, that's like the area of our rectangle, and then we'll multiply that by 2. You wouldn't necessarily need the parentheses there, but we can see that here is our area of the front, and we'll multiply it by 2 because we're going to get the area of the front and back. So multiplying those 3 numbers out, we get 216,000 square centimeters. Okay, so 216,000 square centimeters is the area of the front and back. Left and right side. So let's think about the dimension that is left here. On the left side, we're thinking about how wide the cake is, the width of the cake. So that actually is going to be the 400 centimeters. And when you're thinking about the left or right side of a cake, the other dimension is going to be how tall the cake is. so 180 centimeters. So again, area is equal to base times height. And again, we are going to multiply it by 2 because we're looking at the left and the right side of the cake. So area is going to be equal to 400 times 180, right? That's the area of the rectangle, and then we're going to multiply it by 2 because there's the the left and the right side. So that comes out to 144,000 square centimeters. So we will write that below. Okay, so now we have the components to our area, and now let's just total those up. So we're going to take 240,000 plus 216,000 plus 144,000. If you're punching those in the calculator along with me, you'll find that comes out to a nice even 600,000 square centimeters of frosting. So that's how much frosting that we're going to need in terms of its area. But notice the question goes on past that. It says, how many liters of frosting are needed if 1 liter of frosting covers an area of about 1,200 square centimeters? So this is where we're going to bring in our conversions, kind of like what we do in science. So we start off with our 600,000 square centimeters of frosting, and we're just going to make a little chart here. Now it said for our conversion that 1 liter is equal to 1,200 square centimeters. We want to end up with liters of frosting, so we're going to put the 1 liter part on top. And how much is 1 liter of frosting? Well, it's 1,200 square centimeters according to the problem above. So now we can cancel out our units on the top and bottom, and now we have liters left, which is what we want. So multiplying across, 600,000 times 1 is, of course, 600,000. And liters would be the unit there. And multiplying across on the bottom, well, we just have the 1,200. So dividing by 1,200, 600,000 liters divided by 1,200, if you're doing that on the calculator, hopefully you get 500 liters. So 500 liters would be our final answer. Notice how organizing this problem ahead of time helped make the math appear to be hopefully much more clear, and hopefully you can follow the steps there to get us to our answer of 500 liters.